This is home. This single, shimmering point of light, a pale blue suspended in the vast, black ocean of the cosmos. We call it Earth. It is our cradle, our fortress, the only world we have ever truly known. Every act of human creation, every symphony, every desperate war, every whispered "I love you," and every final, gasping goodbye has happened right here on this fragile sphere. It is the solitary stage upon which our entire, complex, and contradictory history has unfolded. We are, in every sense of the word, the children of this planet. Or so we have always believed. And like all children, we eventually grew restless in our cradle. We looked up, past the thin veil of our atmosphere and into the overwhelming darkness of our room, the solar system. We looked at the silent, winking lights in the sky and we asked a single, profound, and perhaps deeply lonely question. Are we alone? This question has become the driving force of our civilization. It has fueled our greatest scientific endeavors, our most imaginative fictions, and our deepest existential anxieties. We have built mountain-sized telescopes to listen for a whisper and have launched robotic emissaries on decades-long journeys, all just to find a signal, a shadow, a single sign that we are not a singular, unrepeatable miracle. For all our searching, we have held a very specific image in our minds. We have searched for aliens in the classic sense. A life form that is fundamentally other. We imagine them arriving in great, silent ships, or as strange microbes on a distant moon. But this entire galaxy-spanning search is predicated on one enormous and unspoken assumption. We assume that we are the baseline. We assume this blue-green Earth is point A, for life, the definitive original source. What if that assumption is the single greatest mistake in our scientific history? For centuries, we have been haunted by our nearest neighbor. We call it the red planet, Mars. It hangs in our night sky like a drop of old blood, a cold, rusted artifact of a time long past. Today, it is a desolate, frozen desert, a monument to a dead world. We send our sophisticated rovers to crawl its dusty plains, their cameras searching for chemical fossils of life that might have been billions of years ago. We look at Mars as a failed Earth, a tragic cautionary tale. But what if we've been looking at it all wrong? What if Mars isn't the cautionary tale, but the prologue? This investigation will explore a hypothesis so profound, so utterly transformative, that it rewrites not just our history, but our very identity. The premise is this: life did not begin on Earth. It began on Mars. For billion years ago, it was Mars, not Earth, that was the cradle. We are not Earthlings, not originally. We are the descendants of a microbial diaspora, the last, accidental survivors of an ancient interplanetary journey. The alien we've been looking for, the other we've been searching for, is us. We are looking at it in the mirror. This is not a story of if. It's a story of how. We will follow a chain of evidence that connects two young planets, poised on the edge of cosmic history. It's a story of a global cataclysm, a planetary-scale disaster so violent it literally blasted pieces of a world into space. We will animate the death of a planet. But this investigation will show that this very apocalypse, this great dying on Mars, may have been the great send-off. We will explore how this catastrophe on one world may have been the trigger that pushed life, clinging to fragments of rock, toward a new home, a second cradle that was, by coincidence, just becoming hospitable. The implications are staggering. If this hypothesis holds, it would mean life is not a precious, fragile accident unique to this one world, but a tenacious, cosmic traveler, a refugee that jumps from planet to planet. It would mean that every time we look at that faint red point of light in the sky, we are not looking at an alien world. We are looking at our lost, ancestral homeland. The search for life on Mars is therefore a misnomer. We are the life from Mars. The rovers we send there aren't just geologists. They are paleontologists, searching for the deepest roots of our own, forgotten family tree. The question for this film is not, are we alone? The question is, before we existed, did a global cataclysm on Mars push life towards Earth? When we picture the dawn of life, our imagination is drawn to a very specific place. We see a primordial ocean on a young Earth, a warm, churning chemical soup bubbling under a hazy sky. We call it the primordial soup, the warm little pond Darwin imagined. It is the story of our creation, the Genesis chapter of our planetary biology. In this narrative, Earth is the protagonist, the chosen one, the single point of fertile light in an otherwise sterile solar system. And in this story, Mars has always been cast as the foil. We see Mars as the eternal wasteland, the iron-red graveyard of possibilities. It is the what-if planet, the world that might have had a chance but failed. Our rovers send back postcards of a planet that is beautiful, but fundamentally tragically dead. It is a world of dust and rust, scoured by radiation, and locked in a cryogenic freeze. It seems self-evident that life would choose the warm, wet, dynamic Earth over that. But this entire story, this comfortable narrative of our own specialness, hinges on a critical error. We are comparing the wrong planets. We are comparing the Earth of today, or even the Earth of 3.5 billion years ago, with the Mars of today. To find the true cradle, we must rewind the clock, not just to the beginning of life, but to the era just before it. We must travel back 4 billion years, to the Hadean and early Archean eons. And when we do this, when we look at the two infant planets side by side, the script is flipped so dramatically it challenges our very identity. The paradise was not here. It was there. For billion years ago, our Earth was a special kind of hell. It was a roiling, chaotic ball of molten rock, a world still reeling from its own violent formation and the colossal impact that created our moon. The planet was pocked with magma oceans, perpetually bombarded by planet-shattering asteroids left over from the solar system's construction. Its atmosphere was a thick, toxic soup of methane, ammonia, and carbon dioxide. Its surface was a barely cooled crust, constantly being recycled by cataclysmic volcanism. This was not a cradle. It was a forge, and a violent one at that. Now, let us look at Mars from the same moment in time. The picture, which our rovers have been piecing together from ancient geology, is stunning. The Mars of 4 billion years ago was not red. It was blue. It was a world with a thick atmosphere, dense enough to support vast, stable oceans of liquid water. We have seen the fossilized deltas, the dry riverbeds, the shorelines of ancient seas. It had clouds, it had rain, it had snow. Critically, it also had a strong, protective magnetic field, just like Earth's, shielding its surface from deadly solar radiation. But the case for Mars gets even stronger. It's not just about water. It's about the ingredients. Life, as we know it, needs more than just H2O. It needs a complex pantry of elements to build things like RNA, the likely precursor to DNA. Two of those key ingredients are boron and molybdenum. On early Earth, these elements were likely locked away, or not present in a form that life could easily use. But on Mars, the chemistry of its early water suggests these minerals were oxidized and available in abundance. Why does this matter? Boron is thought to be a crucial stabilizer for ribose, the R in RNA. Without it, the delicate precursor molecules for life would simply fall apart in water. Molybdenum is a critical component for enzymes that allow organisms to process nitrogen. In essence, Mars wasn't just wet. It had the right kind of wet. It was a better-stocked laboratory. The chemical environment was not just habitable. It was pre-biased toward forming complex, life-bearing molecules. So let us set the stage again with this new knowledge. You have two planets. Planet A, Earth, is a chaotic, acidic, magma-blasted world, poor in the key ingredients for building life. Planet B, Mars, is a stable, temperate water world, rich in the exact chemical catalysts needed to build RNA. Where would you place your bet? The evidence points to an inescapable conclusion. The conditions for life to emerge were not just present on Mars. They were better. Life doesn't wait for the perfect moment. It seizes the first moment. And all the data we are gathering suggests that the first good moment in our solar system happened on Mars. It was the planet that had the head start. It was the cradle that was ready first. Our own planet, in the meantime, was still the backup plan. A violent younger sibling slowly, over hundreds of millions of years, cooling its temper and getting ready to receive a visitor. The question was never if life could start. The question was where it would start first. And the answer, it seems, was not here. So we have a picture of a young, vibrant Mars. A world of deep oceans, flowing rivers, and a temperate climate. A world statistically more likely to produce life than our own. It was, for a time, a paradise. But one look at the Mars of today, the cold, dead, rusty relic, tells us the story does not have a happy ending. That paradise was lost. The great mystery, then, is not did Mars have water? But where did it all go? What kind of apocalypse can turn a blue-green world into a red desert? The first part of the answer is a tragedy written in planetary geology. Mars, it turns out, was doomed from the start by a single simple fact. Its size. It is a smaller world than Earth with only about 1/10 the mass. A smaller planet has a smaller engine. Its molten core, the dynamo that generates a planet's protective magnetic field, was destined to cool and solidify much, much faster than our own. It was a ticking clock it could not escape. And somewhere around 4.1 billion years ago, that clock ran out. The liquid iron dynamo in its heart seized. The magnetic field, a planet-wide force field, flickered and died. For any fledgling life, this was the moment the sky fell. The shield that protected them from the sun's most sterilizing radiation was gone. The gates were open, and the barbarian was at the door. The barbarian was the solar wind. Not a gentle breeze, but a relentless, million-mile-per-hour hurricane of particles from our sun. With Mars's shield down, this cosmic sandblaster made a direct hit. It began to violently strip the Martian atmosphere, molecule by molecule. The air grew thin. The pressure dropped until the liquid oceans boiled away into space. This was the great dying, a slow planetary asphyxiation. This is where the conventional story of Mars ends. A slow, tragic fade. But for our investigation, this is incomplete. A slow atmospheric stripping doesn't explain our hypothesis. This process kills a planet, but it doesn't move life. You can't evaporate a microbe and have it land on Earth. To get life from Mars to Earth, you need a vehicle. You need a rock. And to get a rock into space, you need something far more violent. Our hypothesis proposes the slow death was punctuated by a sudden one. We need an event, a single moment so powerful it could accelerate Mars's climate collapse and physically eject pieces of the planet into space. This was not a gradual decline. It was a red apocalypse. The prime suspect is the one force in the early solar system capable of such violence. A colossal asteroid impact. We are not talking about the asteroid that killed the dinosaurs. We are talking about something far larger, a rock the size of a small country, a rogue planetesimal from the chaotic, unfinished solar system. We must imagine a planetary-scale billiard shot. The impact would be unimaginable, liquidating a continent and releasing energy dwarfing all of Earth's nuclear weapons combined. The physics of such an impact are terrifying. The shockwave would crack the planet's crust. But crucially, the rebound would be so powerful it would overcome Mars's own gravity. It would launch billions of tons of debris, not just dust, but entire mountains of solid rock, upwards, punching them clean through the thinning atmosphere and past Mars's escape velocity. These rocks were now in orbit around the Sun. This single event provides the two key plot points. First, it was the Great Dying, the final blow that shattered Mars's biosphere and accelerated its path to a frozen desert. But at the exact same moment, it was the Great Send-Off. This was not just an act of destruction. It was an act of expulsion. It was the violent push our hypothesis requires. Mars was now seeding the solar system with pieces of itself. Think of it this way. In its final, agonizing moment of planetary collapse, Mars didn't just die. It sneezed. It was a convulsion, a last, desperate reflex. And inside that cloud of ejected debris, inside those billions of tons of rock blasted into the void, were the last microscopic survivors of the Martian paradise. They were dormant. They were frozen. But they were on their way. The apocalypse on Mars was over, but the journey to Earth had just begun. So we have a cataclysm, a planet-shattering impact that turns Mars into a refugee camp, launching billions of tons of its own crust into the dark. And we have our survivors, microscopic life forms, We'll call them extremophiles, that have already proven they can survive in harsh conditions. We have the push, and we have the passengers. But we need the most critical piece, the lifeboat. This is the central, practical question of our entire hypothesis. Can a rock, ejected from one planet, carry life to another? This theory has a name. It is called lithopanspermia. The word means stone seeding. It is a bold, fantastic idea, and for a long time it was pure science fiction. The journey from Mars to Earth is not a simple trip. It is a gauntlet, a series of 3 seemingly impossible trials. To prove our hypothesis, we must prove that life could survive all 3. First, the launch. Second, the journey. And third, the landing. Any one of them should, in theory, be a sterilizing event. But what does the evidence actually say? Let's start with hurdle 1, the launch. This is the moment of the asteroid impact. It's an explosion of unimaginable violence, liquefying rock and carving a crater the size of a continent. Surely anything near that blast would be vaporized, turned into sterile plasma. But the physics of impact are more subtle. The immense shockwave doesn't just vaporize. It also fractures. In a process called spallation, it can accelerate surface-level rocks to escape velocity, 5 kilometers per second, without ever melting them. It's like a high-speed, cosmic-scale chip shot. The lifeboats are launched cold. How do we know this happens? Because we have them, right here. In our museums and laboratories, we have a collection of over 120 meteorites that we have chemically identified as being, without question, from the planet Mars. They are physical proof that the launch mechanism is real. The lifeboats, at least, are arriving. They made the journey. But could their microscopic passengers? This brings us to hurdle 2, the journey. This is perhaps the most terrifying trial. The rock is now in deep space, tumbling through the void for thousands, perhaps millions of years. The passengers inside face a trio of cosmic killers. The vacuum would try to boil their water. The absolute zero temperature would freeze them solid. And, most deadly of all, the relentless solar and cosmic radiation would shred their DNA. It seems like a death sentence. But again, the lifeboat provides. The vacuum and cold, it turns out, are a form of preservation. They would trigger a state of deep dormancy, a suspended animation. The real killer is radiation. And the shield, once again, is the rock itself. Studies have shown that just a few inches of solid rock are enough to block the most damaging solar UV rays and significantly reduce the hard cosmic radiation. It's a natural bomb shelter, and we have found life on our own planet, in the cooling pipes of nuclear reactors, that eats radiation for breakfast. These extremophiles redefine what survivable means. Finally, hurdle 3, the landing. After a million-year journey, our lifeboat finally encounters Earth's gravity. It screams through the atmosphere at 30,000 miles per hour, becoming a shooting star, a blazing fireball. This surely is the final sterilization. The rock must be heated to thousands of degrees, burning its passengers to a crisp. But this is a critical misconception. Only the outside of the rock burns. This process is called ablation. The outer layer vaporizes, creating the fiery streak we see in the sky. But in doing so, it carries all that heat away. The inside of a large meteorite remains almost untouched. When meteorites are found just hours after landing, they are often covered in frost, the cold of deep space still trapped within their core. The fiery entry is a light show, but for the microbes deep inside, it's a smooth, cool ride to the surface. So the launch is survivable. The journey is survivable. The landing is survivable. The how is no longer a question of science fiction. The mechanism is real. And in 1996, we thought we found the smoking gun. A 4.5 billion-year-old meteorite, blasted from Mars and found in the Allen Hills of Antarctica. Its name, ALH 84001. When scientists looked inside with an electron microscope, they found something. Structures. Tiny, segmented, worm-like shapes that looked, for all the world, like fossilized bacteria. The scientific world erupted in a firestorm of discovery and debate. Were these the first Martians? The first confirmed aliens? Or were they just strange, non-living mineral formations that mimicked life? The controversy rages to this day, and the jury is still out. But in a way, the debate almost doesn't matter. Whether ALH 84001 carried life or not, it is the proof. It is a 4-billion-year-old piece of Mars that successfully completed the entire impossible journey. The lifeboats are real. The highway between the worlds is open. The only question left is, was there cargo? We have established a mechanism. The red apocalypse on Mars, a cataclysm powerful enough to launch its own rocks into space. And we have established a vehicle, the interplanetary lifeboat, a piece of stone capable of protecting its microscopic cargo from the horrors of the launch, the journey, and the landing. The how is possible. The if is no longer a fantasy. But the most compelling part of this story, the piece that transforms it from a what-if to a what-was, is not a question of physics. It is a question of timing. This is where our investigation uncovers the single greatest coincidence in the history of our solar system. The chain of evidence is only as strong as its links. We have the push from Mars, and we have the reception on Earth. Our hypothesis rests entirely on whether these two events, the death of one world and the birth of another, happened at the same time. If they are separated by 1 billion years, our story is just a story. But if they overlap, if they happen in the same geological instant, we have found the motive, the weapon, and the opportunity. Let's look at the timeline. The evidence for ancient life on Mars, the oceans, and the magnetic field points to a paradise that existed roughly 4.1 to 3.8 billion years ago. The evidence for the Great Cataclysm, the end of that paradise, also centers on this exact window. This is when Mars died, when it was blasted, when it sent its refugees into the void. Now let us look at Earth. What was happening here at that exact same moment? It was the Great Unveiling. For hundreds of millions of years, Earth had been the magma-blasted hellscape we saw earlier. But by 3.8 billion years ago, something miraculous was happening. The planet's crust had finally cooled. The relentless, planet-sterilizing bombardment was easing. And for the first time, liquid water could remain stable on the surface, not as a boiling, acidic soup, but as vast, planet-wide oceans. Our world, after a violent and chaotic infancy, was finally becoming habitable. Do you see it? This is the great coincidence. It is the most dramatic handoff imaginable. At the precise moment Mars is becoming a sterile, frozen desert, Earth is becoming a temperate, water-filled paradise. One cradle is emptying just as another is being prepared. It is a cosmic changing of the guard, a perfect alignment of timelines. The fugitives were launched from a dying world just as a new, fertile continent appeared across the sea of space. The timing isn't just possible. It is perfect. Now, let's trace the journey of that one specific lifeboat. Let's follow a single rock, ejected from Mars, as it tumbles through the void. For 1,000 years or 100,000, it travels. Its passengers are dormant, frozen, their metabolic processes stopped. They are in a state of suspended animation, preserved by the vacuum and the cold. This rock, a tiny piece of Martian crust, is a silent ark, carrying the most precious cargo in the universe, the spark of life. Finally, its long journey ends. It is captured by Earth's gravity. It blazes through the new, nitrogen-rich atmosphere, its outer layers ablating in a fiery streak. It slows, tumbles, and crashes into a vast, primordial ocean. The impact is violent, but the rock's cold interior is protected. It settles on the seafloor, perhaps near a warm, nutrient-rich hydrothermal vent. And for the first time in millennia, the ice inside its porous cracks begins to melt. This is the moment of reawakening. The dormant microbes, the Martian survivors, sense the change. They are no longer in a frozen vacuum. They are in a new home, a new world filled with water, warmth, and the chemical food they need. They wake up. They begin to repair their DNA, to metabolize, and to do the one thing life is programmed to do: replicate. The seeding is complete. The Martian diaspora has found fertile soil. This wasn't just a single lucky shot. The great coincidence has another name: the late heavy bombardment. This was a period from about 4.1 to 3.8 billion years ago, when the entire inner solar system was a cosmic shooting gallery. Massive asteroids were pummeling all the planets, including Mars and Earth. This wasn't just a highway, it was a superhighway. Material was being exchanged between the two planets constantly. This wasn't a one-in-a-million chance. It was an inevitability. In this chaotic environment, Earth was being seeded with rocks from all over the solar system. But only the rocks from Mars, the only other habitable world at the time, could have been carrying passengers. This bombardment was the very mechanism that made the transfer of life not just possible but prolific. The great coincidence wasn't a coincidence at all. It was a delivery system. Mars didn't just send one lifeboat, it sent a fleet. So we have followed the trail. We have laid out a chain of evidence. A story of two planets, a terrible catastrophe, an impossible journey, and a single, tenacious survivor. We have built a case, brick by scientific brick, for a hypothesis that rewrites our entire origin story. This is a grand, dramatic, and scientifically plausible narrative. But it leaves us with one final and profoundly disquieting question. So what? If this is true, what does it truly mean? It means that our most cherished belief, that life is a singular, terrestrial miracle born of this planet, for this planet is shattered. It means the primordial soup wasn't our own. It was borrowed. It means that life is not a delicate, localized accident, but a tenacious, cosmic traveler, a refugee that treats planets as mere stepping stones. Life in this new story is not a product of Earth. Earth is merely the product of life. It is the lifeboat that successfully crossed the ocean. And what, then, does that make us? For all of our recorded history, we have defined ourselves by this world. We are Earthlings. We draw our myths, our identities, and our very atoms from this soil, this water, this air. But if this hypothesis holds, this is not our ancestral homeland. It is our adopted home. We are the descendants of an ancient, microbial diaspora. We are the children of a world we have never known, a world that is now a red, frozen graveyard. We are the survivors. This investigation fundamentally reframes our search for aliens. We have spent billions of dollars and pointed our greatest instruments at the heavens, listening for a whisper, searching for them. We have looked at Mars, our nearest neighbor, as the most likely place to find them. We have been looking in the wrong direction. The alien we have been searching for, the other we've been desperate to find, is us. We are the Martians. Our biology, our core biochemistry, the very first spark of replication that has led, over 4 billion years of unbroken evolution, to the mind that is processing these words. That spark was not ignited here. It was carried here, dormant, in a piece of cold, dark stone. We are the extraterrestrials. We are the living, breathing, thinking proof that life exists beyond Earth because we are that life. The alien in the mirror is not a metaphor. It is our reflection. And that faint red point of light in our night sky, it is transformed. It is no longer just a target for our curiosity, a cold, distant world to be colonized or studied from afar. It is, in the deepest and most literal sense, our past. It is the lost continent of our own biology. When we look at Mars, we are not looking at another world. We are looking at the ruins of our first world. It is the Garden of Eden from which we were, quite literally, blasted. This changes the meaning of our entire space program. The rovers we send to crawl its dusty plains, Curiosity, Perseverance, they are not just geological tools. They are engaged in the most profound archaeological dig in human history. They are not looking for life on Mars. They are looking for the roots of our life on Mars. They are not biologists searching for aliens. They are paleontologists searching for the most distant, most forgotten fossils of our own ancient family tree. We are left here on this second world, looking back at our first. We are the survivors of a planetary shipwreck, the beneficiaries of a cosmic coincidence. The question we started with, are we alone, is now revealed to be the wrong question. It has always been the wrong question. We have always known, deep down, that we are the children of a vast and complex universe. The real question is not about our loneliness. It's about our resilience. The question is not, are we alone? The question is, did we survive? And the answer, written in every strand of our DNA, is yes.